In the vast expanse of space, astronomers have discovered something extraordinary, an enormous region of nearly absolute emptiness that challenges everything we thought we knew about our universe. In 2007, researchers studying deep space surveys noticed something peculiar, a region in space where galaxies simply weren't there. This wasn't just a small gap in the cosmic web, but something far more significant. The scale of this cosmic void is almost impossible to comprehend. Spanning roughly 330 million light-years across, it's so massive that 10,000 galaxies the size of our Milky Way could fit comfortably inside it. This region became known as the Giant Void, and its discovery sent shockwaves through the astronomical community. In a universe that should be relatively evenly distributed with matter, how could such an enormous empty region exist? Our models of the universe predicted that matter should be spread out somewhat uniformly, with cosmic structures forming along web-like filaments. But here was a region that seemed to defy these fundamental principles. The void's discovery posed immediate problems for our understanding of cosmic evolution. It wasn't just unusually empty, it was impossibly empty, according to our best theories of how the universe should work. The boundaries of the void are particularly striking. While space is never truly empty, this region contains less than 1/10 of the matter we would expect to find in a volume this size. Statistically speaking, finding such a massive void is like flipping a coin and getting heads 1,000 times in a row. The odds seemed so remote that many astronomers initially doubted the findings. As observations continued to confirm the void's existence, scientists were forced to confront an uncomfortable reality. Our universe contained structures far more extreme than anyone had imagined possible. The void's nearly perfect spherical shape added another layer of mystery. Natural structures in space tend to be irregular and chaotic, but this cosmic desert appeared to have an almost engineered precision to its boundaries. The existence of the giant void doesn't just challenge our understanding of space. It breaks some of our most fundamental theories about how the universe works. According to our standard model of cosmology, the early universe was incredibly uniform. Over time, gravity should have caused matter to clump together in a fairly predictable way, forming a cosmic web of galaxies and clusters. But the void presents a puzzle. Dark matter, which makes up most of the universe's mass, should have created a gravitational framework that would prevent such large, empty regions from forming. The amount of missing matter in the void is staggering. It's not just galaxies that are absent. The region lacks the basic building blocks that should exist everywhere in space. Even the sparse gas that typically fills space is largely absent. The void contains less than 10% of the matter density we would expect to find in an average region of space this size. This severe emptiness poses a particular problem for our understanding of dark matter, which should be nearly impossible to remove from such a large region of space. Dark matter's gravitational influence should act like a cosmic scaffold, preventing the formation of such large empty regions. The void's existence suggests either our understanding of dark matter is wrong, or something else is at play. When scientists run computer simulations of galaxy formation, nothing even approaching the size of this void appears. Our most sophisticated models simply cannot explain how it formed. Some researchers suggest the void might be evidence of processes that occurred before the Big Bang itself, challenging our entire picture of cosmic history. The void's perfect spherical shape and enormous size suggest it might be a remnant of quantum fluctuations from the universe's earliest moments, preserved and expanded during cosmic inflation. As we continue to study this cosmic desert, we're forced to consider an unsettling possibility that some of our most basic assumptions about the laws of physics might be incomplete, or even incorrect. As astronomers grapple with the giant void's existence, several fascinating theories have emerged to explain how such an enormous empty region could have formed. One leading theory suggests that dark energy, the mysterious force causing our universe's expansion to accelerate, might behave differently in certain regions of space. A particularly strong pocket of dark energy could have literally pushed matter away from the void region over billions of years. Another explanation takes us back to the earliest moments of the universe. Quantum fluctuations, operating at microscopic scales, could have been stretched to enormous sizes during cosmic inflation, creating regions with significantly different properties. Before speaking about some of the more exotic theories that might explain this cosmic mystery, I want to take a quick moment to ask you to subscribe to the channel. Your support helps us continue exploring these fascinating space phenomena and ensures you don't miss our upcoming videos about other mind-bending cosmic discoveries. Now, let's dive into one of the most controversial explanations for the void's existence: the simulation hypothesis. Some physicists have noted that the void's nearly perfect spherical shape and sharp boundaries resemble something you might find in a computer simulation, an artifact or glitch in the cosmic code. Natural structures in the universe tend to be irregular and chaotic. The void's geometric precision is so unusual that it's led some researchers to seriously consider whether our universe might be an elaborate simulation. Moving to more conventional explanations, some astronomers propose that the void might be the result of a primordial bubble in the fabric of space-time itself. This bubble theory suggests that a unique phase transition in the early universe created a sphere of slightly different space-time properties, preventing matter from collecting within its boundaries. Whatever its origin, the void acts like a cosmic laboratory, allowing us to study how the universe behaves in the absence of matter. By studying the few galaxies that do exist within the void, astronomers have discovered that the laws of physics might operate slightly differently in these empty regions, providing crucial clues about the nature of dark energy and gravity. Recent observations have revealed something unexpected about the giant void. It's not completely empty after all. A handful of galaxies do exist within this cosmic desert, and they're unlike anything we've seen before. Deep within the void, astronomers have discovered several dwarf galaxies that seem to defy our understanding of galaxy formation. These void galaxies have evolved in almost complete isolation, free from the gravitational influences that shape most galaxies. These void dwarf galaxies are remarkably different from their counterparts elsewhere in the universe. They're unusually blue, indicating recent star formation, and they contain far more dark matter than expected for their size. These isolated galaxies serve as pristine laboratories for studying galaxy evolution. Without interference from neighboring galaxies, they show us how cosmic structures develop in their most basic form. One of the most surprising discoveries is that these void galaxies are still forming new stars, despite lacking the gas and dust usually needed for star formation. They seem to have found ways to retain their star-forming material that other galaxies typically lose. According to our previous understanding, these galaxies should have exhausted their star-forming material billions of years ago. Their continued activity suggests they've developed unique mechanisms for recycling and preserving their gas. These void galaxies aren't just surviving, they're thriving in ways that challenge our models of galaxy evolution. Their existence suggests our understanding of what galaxies need to survive might be fundamentally flawed. The chemical makeup of these galaxies is equally puzzling. They contain elements in proportions that shouldn't be possible without interaction with other galaxies, suggesting they've developed entirely different chemical evolution pathways. In many ways, these void galaxies are like cosmic time capsules, preserving conditions from the early universe that have long since disappeared elsewhere. Recent observations suggest these void galaxies aren't completely isolated after all. They appear to be connected by thin filaments of dark matter, forming a delicate cosmic web within the void itself. This discovery of a miniature cosmic web within the void might finally help explain how these galaxies have managed to sustain themselves for billions of years in what should be a cosmic desert. The giant void and its mysterious inhabitants aren't just challenging our understanding of the universe. They're forcing us to completely rewrite it. We now know the giant void isn't unique. Astronomers have discovered numerous other voids throughout the universe, though none quite as large or empty. Together, they form a crucial part of the universe's structure that we've only begun to understand. Rather than seeing voids as empty spaces between galaxies, we're beginning to understand them as fundamental cosmic structures that actively shape the universe around them. They're not holes in the cosmic web. They are the cosmic web. The properties of void galaxies have triggered a major reassessment of dark matter theory. Their unexpected behavior suggests dark matter might have properties we never considered before. Instead of dark matter being evenly distributed through space, these voids suggest it can be pushed around by forces we don't yet understand. This might explain why some galaxies seem to have much more dark matter than others. These cosmic voids might offer us a glimpse into the future of our universe. As dark energy continues to accelerate the universe's expansion, more regions will likely become void-like. The giant void might be showing us what the distant future of cosmic evolution looks like. If current trends continue, the spaces between galaxy clusters will grow ever larger. Eventually, most of the universe could resemble the giant void, with galaxies existing only in isolated groups. The void has become a testing ground for some of the biggest questions in physics. Scientists are using the void to test competing theories of gravity, dark energy, and even alternative models of physics. Its pristine emptiness makes it perfect for observing these fundamental forces without interference. As we continue to study these cosmic deserts, each discovery brings new questions. But one thing is certain: the universe is far stranger and more complex than we ever imagined. The story of the giant void reminds us that in science, sometimes the most important discoveries come not from what we find, but from what we don't find. Thanks for watching, and remember to subscribe for more explorations of our mysterious cosmos.